Here's another example of a limit that we can evaluate using a table. Actually, it turns out you can evaluate pretty much any limit using a table, but we'll look at other techniques as we go forward in this chapter as well. So we have the limit as x approaches 3 of 1 divided by x minus 3. And I've already set up a table for us, giving some x values that approach 3 both from the left-hand side, 2.9, 2.99, 2.999, and values that approach from the right-hand side, starting from the far right, 3.1, 3.01, 3.001. I've also put this function into my calculator. Again, using the y equals menu, I put it into y1. I made sure I put parentheses around the bottom so I didn't have any problems with the division there. My table settings are still set to ask as they were in the previous video, and I'm using the table function once again to fill in my numbers. So when x is 2.9 for this function, I get negative 10. And when it's 2.99, I get negative 100. When it's 2.999, I get negative 1000. So it doesn't look like we're approaching anything. It looks like these numbers are getting more and more negative. On the right hand side, if we start way over at 3.1, we'll get 10. At 3.01, we'll get 100. And at 3.001, we'll get 1000. So again, it doesn't look like we're getting close to any particular number. It looks like these numbers are getting larger and larger and larger. But the fact that we're not approaching any single number from left and right, at this point we've got negative 1000 on the left and we've got positive 1000 on the right. If we probably went closer and added decimal places, it looks like from the pattern we'd end up with negative 10,000 and positive 10,000. We're just going to get further and further and further away. So that implies that this limit does not exist. And we can write that by saying that the limit as x approaches 3, 1 divided by x minus 3, d n e for does not exist. Some people write equals does not exist here. That's fine. I'll accept it either way. One thing you should note that's a little bit different here, this isn't always a guarantee that you end up with a does not exist, but I do want you to notice that in this case if we plugged 3 in directly, we'd end up with 1 divided by 0, not 0 over 0, which is our indeterminate form. 1 divided by 0 often, but doesn't always have to lead to d n e.